Good morning, good afternoon, and good evening, everyone. In this video, we want to show the result of a POC Greg and I conducted with ServiceNow and Hedera. We will cover a e-procurement use case where multiple organizations need to collaborate through a multi-party business process in an orchestrated but trustless environment. We will do that establishing a ServiceNow AppNet that represents a multi-company value stream. So this is the agenda for the session. Firstly, we will briefly present the e-procurement use case. Secondly, we will describe the AppNet architecture and how we can leverage that for e-procurement. Then we will describe the demo flow and see it in action. And finally, we will conclude with a few takeaways. Let's start with the use case then. In a traditional negotiation system, the buyer needs to establish one-to-one connections with every supplier. As a consequence, these processes are still very manual because the buyer needs to act as an hub of the entire negotiation process. In an e-procurement setup, the suppliers constitute a network where the buyer can submit its request and select the best bid. This setup provides a greater opportunity to digitize a multi-company business process using a common protocol. The supplier network must be trustless because it contains entities which are in direct competition. Hence the benefit of using a distributed ledger technology like Hedera in order to guarantee these interactions. The concept of e-procurement is widely discussed in the book by Dr. Larsen that has been recently published. As we are keeping the demonstration quite conceptual, I would recommend this book to dig deeper in the industry needs and experiences. E-procurement is extremely relevant across multiple industries. Public tenders are a sweet spot for optimization and better transparency. Manufacturing implements e-procurement to manage high-throughput business networks and streamline supply chains. In telco, there are significant applications in the domain of collaborative bidding, where multiple operators can bid for different network segments for the same connectivity request. A financial institution like a bank can be involved in trade finance and may need to inspect the supply chain to evaluate carbon emissions. Now, let's talk about AppNets. So, what is a ServiceNow AppNet? It is a distributed collaborative application installed on multiple ServiceNow instances that uses the Hedera DLT to exchange signed, verifiable change of state of the ServiceNow database. The ServiceNow instances, which are part of the same AppNet, can scale to any size, from a few to tens, hundreds, or thousands. Each ServiceNow instance connects to Hedera through the DLT nodes and receives back information in the form of messages through the Hedera mirror network. An instance can also be part of multiple AppNets, each AppNet supporting different use cases and business networks. Looking at the full stack, at the very bottom you have the Hedera DLT, made by the nodes operated by the council members. Over the Hedera network, we will be using the Hedera consensus service to streamline messages from the ServiceNow organization authorized to submit. The connection between ServiceNow and Hedera happens through a specific connector that we call Hnow, made by a scoped application and a mid-server component. Over the connector, we have the actual AppNet, which defines a shared data model between all participants. Over this shared data model, every organization can build its own custom business processes that can reference the shared data model and be triggered by events in the multi-party workflow. For example, the buying organization may trigger the purchase order when the e-bidding process is completed. A key part of the interaction happens at the interface between the ServiceNow environment and the DLT, also called Layer 2. From an architectural perspective, each individual instance is comprised of a scoped application called Hnow that sends messages to the consensus service using the Hnow API on the mid server and receives messages through a daemon process called message loader, also using the mid. Both the Hnow API and the message loader have been developed in the context of this POC. AppNets that interact with the Hedera are represented by App1 and App2, and they are installed on all ServiceNow environments. E-procurement is the AppNet we have developed in this POC. The participants to the business network are the customer or the buying party, the suppliers or the bidding parties, and the third party like an auditor. In a real-world situation, each party will normally have a different ServiceNow instance, but it's also possible that multiple participants reside on the same environment, still signing transactions with different private keys, for example, different departments or legal entities. The participants collaborate through a shared and verified data model where every change of state must go through the Hedera consensus service. In the case of e-procurement, the data model is represented by two tables for ask and bid, which are connected by one-to-many relationships. Customer place its ask for goods or services in the ask table, and bidders submit their bids for that ask. The AppNet also implements a workflow where the record goes through different phases like a distributed state machine. A third party is authorized to inspect the e-procurement network in read-only mode. Now I will hand over to Greg for an introduction of Hedera and the consensus service.
Thank you, Nicola. The consensus service is one of many services offered by Hedera, which is a public distributed ledger. Thanks to high throughput and low, predictable transaction fees, Hedera has already processed over 1.5 billion transactions in just over 2 years. Finally, University College of London has recently concluded a study showing that Hedera is the most energy-efficient public DLT per transaction. After creating one or more topics, the Hedera consensus service enables multiple participants to issue messages to these topics. These messages are put in consensus order by Hedera and given a fair immutable timestamp. Anyone subscribing to a topic will receive these messages in the same order, and with each participant processing the messages in the same order, at any given timestamp, their states are synchronized. Let's dive into how this demonstration uses HCS. A ServiceNow instance generates a message, which could be a proposal or a bid. That message is included in the Hedera consensus service transaction to submit it to a topic. The transaction is sent to a Hedera consensus node. The Hedera network reaches consensus on the transaction, and the transaction is shared with all mirror nodes. Every ServiceNow instance subscribing to the topic is now aware of the transaction and the message within. It can therefore process it. For example, if the message is a proposal, all bidders are now aware of the new proposal. In addition to sending asks and responding to bids, in this demo, each participant generates a hash of its own state and submits the hash to the Hedera consensus service via another transaction. The verification hashes each reach consensus on Hedera and are shared with mirror nodes. And every participant receives the hashes of the other participant states and is able to verify that all participant states are identical. Nicola will now walk us through the demo.
Okay, thanks, Greg. It's time now to dig in the demonstration and the demo personas and the actual demo flow. So we have three main personas for the demonstration. The first one is the customer requesting a service or product to their supplier network. Then we have the actual supplier network made by vendor, which are bidding for the customer services, and then an auditor, an organization which must audit and inspect the process and derive a perspective of scoring about the customer and the suppliers. This is a graphical representation of the demo setup. On Hedera, we will be using two different topics, the main topic where the change of state are sent and the verification topic where the state consistency messages are sent. The first instance, called Hnow1, represents the customer. The second instance, called Hnow2, hosts all the participants in the supplier networks, just to avoid having too many instances. The third instance, called Hnow3, hosts the auditing organization. The application within the instances represents the AppNet. The bottom part of the diagram is the on-chain layer, while the upper part is the off-chain layer, entirely built on ServiceNow. Here is the demo story. The ask record follows a flow represented here. The customer will submit the ask at the beginning of the process. The bidders are then allowed to bid for that ask, and finally the customer will accept one of the bids, closing the tender. The auditor is able to inspect the entire life cycle of the ask from submission to the final tokenized state. Let's jump then into the live demo. Okay, this is the demo environment. It's made of three different instances: the customer instance, the supply chain instance where all the vendors resides, and the auditor instance. All the three instances use the same machine for the AppNet processes, and I can see all the processes running on that machine. So let's start on the customer side and let's open the Hedera environment. There are two different components. The first one is the Hnow Connector that is managing the cryptographic key for the different participant. Each key has a name, the same as the participant, and the public key is visible and the private key is not visible, but you can see which one are actually hosted on that environment. Then you have the participants, and on that environment there are just the customer, and there are a user that is used for the verification process. Okay, so this is the description of the um, Hedera application, and then you have the application that is built on top of the connector, in this case, the distributed marketplace or e-procurement application. Let's start then the process as the customer, and let's create a service ask for the supplier network. So the service ask in that case is going to be something like 10 new production machines. So it's very simple, and I can save that ask locally, but when I hit submit to Hedera, this request is sent to the Hedera network and the state is submitted, but when the message goes to the network and come back through the mirror nodes, the state change to active, as you can see here, and you have the sequence number of the message marked in that field, and the party, which is the participant recognized by the Hedera DLT, is marked here as the customer in that case. If I refresh the message tab, I can see that there is one message that has defined the change of state that we just saw, and we open here the message and we see that each message is represented by the sequence unique number in the topic ID. You have a consensus date time of the network on which all the nodes agrees, the instance that submitted that, and all the cryptographic keys and signatures, and the state consistency field that represents the overall state of the ask and also bid table for every change of state in such a way that we are sure that all the participants are in agreement. Then the state now is of this message is processed, and you have all the details about the participant and the verification of the key that is of the signature that is very important, that tells that the message has been actually submitted by the owner of the key. So under the message is very important that you also get verification messages. So all the instances which are part of the AppNet send back the state consistency message, including the instance itself that originated the change of state, in such a way that you can verify that all the state consistency are in agreement, so everyone is agreeing on the same view of the reality when sequence number 23 was processed. So this is the message from a ServiceNow perspective. You can also open the message in the Hedera Explorer. We are using Kabuto here, and in Kabuto you see similar information and you see the message payload. What is important here is that the message payload in the DLT is encrypted, and so no one actually knows the content of the message, and the privacy is respected. A quick comment here for the most technical: this is not actually encryption, this is base 64 encoding, but the mechanism to enable encryption here are very similar. So now let's switch on instance number 2. Instance number 2 is the supply chain. I'm currently logged in as supplier 1. I have here the exact same application. I have the connector, define the AppNet, and I have the application built on top. So for example, now if I click on the service ask table, I can see exactly the same content that I had on the customer instance. So the last service ask is about 10 new production machines. It is interesting also to have a look to the message table in itself. So here, for example, I can see that if I order by sequence number, I can see that all my messages have this consensus field that should always be 100% because all the nodes must be in agreement about the state of the tables which are under the AppNet control. And I have the same for the verification messages, even if they are a lot more because there are 3 times the main topic messages actually. From the topic, I can also see the same kind of structure in Cabuto. So if I open, for example, the main topic, I can open this one in Cabuto and see the sequence of messages within the DLT Explorer. So now let's move on with the process. So if I go again in the service ask table, I can see that my service ask has been created here by the customer. So as a supplier, I may want to bid for that service ask. So I can enter the service ask and I create a new service bid. Again, this is a record that is being created locally. So I'm going to say bid for prod machines 1. And I can say, for example, the cost is going to be 1 million. And I'm going to produce not more than 5,000 tons of CO2 emission. So I can either submit and save locally or I can submit to Hedera and share with the DLT network. So same kind of mechanism here. The state is initially submitted when the message goes through the network and is being received back from the mirror nodes. The state changes to active. I have the creation message here. I have the party, which is now bidding for that specific service ask. I can refresh the message list and I have exactly the same structure. Within it, I have the message in the main topic with all the information which are shared, and then I have my verification messages, which are now coming. And I have all 3, and the consensus is again 100%. All of them agree on the current state of the ask and the bid table. So now if I come back to the instance 1 to be the customer, let's open the service ask table again. I will order by creation message, and I have my production machine service ask as the last one. And I can see now that under this service ask, I have multiple bids. I just bidded as supplier 1, but at the same time supplier 2 and supplier 3, which lives, by the way, on the same supply chain instance as multiple participants, like departments in a big organization, for example. I've also bid for that ask. So as a customer now, I'm able to select the bid that is more appropriate for my organization. So I can, for example, compare the emission, and I can see that this bid from supplier number 3, even if it's the most expensive, is the lowest one in terms of emissions. So I can go ahead and accept this bid. So I have a button here, accept bid. I can just click, and the mechanism is always the same. The change of state is sent to the network, and all the nodes, including the originating one, are receiving the message back, and they are changing the state. So now I have 2 different messages under that service ask because both of them represent 2 different change of state. And you can see here that the state is currently matched. I can refresh here again. The confirmation messages will come in a moment. Here we are. Also, the last one arrived. So the state of the bid is matched. If I go back to the service ask, I can see that also the state of the service ask has been changed to matched. So the process is completed. And if I have a look to all the service bids, only one is in the state matched, the one coming from 3, and the other one are now in the state cancelled. What is also important is that I have here the button create purchase order, and that showcases how from a distributed process on the AppNet I can start a local process like the creation of a PO, which is entirely managed inside the procurement application. If I move to instance number 3, I have the perspective of the auditor. I can refresh my dashboard and see that the numbers about total emissions of the supply chain are increased because this dashboard is aggregating all the emissions which are propagated to the service ask, and I can have any kind of KPI or report regarding my supply chain. So for example, I can see that there are different views on bids by suppliers, or that I can do an aggregation of the bids for specific service ask, or also the ask by state on the supply chain. This data can be actually be drilled down. So if I click on the matched part of the service ask, I get exactly the same information, which is the only difference that the auditor here has only read access to this information. So if I order again by creation message, I have my production machine service ask here, and you can see already in the list view that the emissions and the cost of the bid that has been accepted have been propagated to the service ask level. Of course, you can interact with the AppNet not just from the classic UI, you can interact also from the service portal, for example. So as a customer, I can place my service ask from the supply chain category, and I can request to create a service ask to the supplier network. This can be something like 20 user experience experts, and it's very simple, but can be as complex as we want. And if we submit that, um, the service ask is created, and is created initially with the submitted state, but you can see that when the message arrive, you have the state changed to active, and you have the visibility on the messages as well. Exactly in the same way, you can represent supplier one, for example, and you can do your bid from the service portal. And in this case, you have a catalog item that is place service bid, where you can select the data like local data, but this is actually AppNet data. And here you see all the service asks which are in the active state. This is the one I want to bid for, and this is going to be bid by a supplier one for a cost of 100K and estimated emission of 777 tons. And I can submit what this submission produce. Of course, in the service ask table of every instance, I'm going to have my service ask with exactly the same structure of messages and the bid placed under that ask, so I can progress in exactly the same way with that process. This concludes the demonstration about AppNet and the e-procurement process, and let's go back to the slides for a few takeaways. Okay, let's conclude with 3 takeaways from today's session. First of all, we have demonstrated how a decentralized market for e-procurement is possible using ServiceNow and Hedera, and leveraging the Hnow platform as the layer 2 technology for the layer 1 DLT. Secondly, we have implemented the first AppNet model in ServiceNow that can be generalized to any situation where a shared business model and multi-party workflow is required. Finally, we have shown how local processes like purchase order management can be seamlessly connected to the shared business process of the AppNet, making this capability even more powerful. Thanks for listening, and we hope you enjoyed today's session.